Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to learn how to graph systems of inequalities. We're going to begin with one that's completely linear, then we'll move on to a second one that's not linear, one of the functions is nonlinear, and then we'll move on to a third one that in addition to being nonlinear has three inequalities to graph at the same time. And what we're looking for here is the intersection. Any ordered pair x, y, in order for it to be a solution, it has to be a solution of the first inequality and the second inequality. So we're going to graph each inequality independently, and then we're going to take a look at where they overlap. So I'll be using a couple of different colors to shade, and then we'll look for where the shading overlaps. Then we'll fill it in with maybe a third color. You can use like one kind of diagonal line for the first one, another for the second, and look for where they cross. That's a good idea. We've got two lines. One of them is in slope-intercept form. One of them is in general form. Notice that both have an equal sign under the inequality, so we're going to use solid lines this time. I'm going to graph the first line in blue. And so here I know my slope is 1/4, so that's up 1, right 4. I know my y-intercept is at y equals 2. So I can start with that point at y equals 2, and then up 1 over 4, up 1 over 4. Moving to the left, I'll go down 1 and 4 to the left, down 1 and 4 to the left. So there's all the points for that line. And again, I drew it as a solid line because of the equal sign underneath it. Now I'm looking for where y is less than that. Since y is isolated here, the less than sign tells me to shade below. So I'm going to use a blue highlighter. I'm going to shade below with lines that have that same slope. So at this point, I'm restricting myself to just values that are shaded in blue. Then I'm going to graph the other inequality, and I take the solutions from that are inside of that region. So this region at the top is completely out because it's not a solution for the first one. Let's get that out of the way. The second one is in general form. 2x plus 3y is greater than or equal to 12. So the x-intercept, which is where y is 0, 3 times 0 disappears. So we're trying to figure out where does 2x equal 12? Well, that's where x is equal to 6. So I've got 1 point there. For the y-intercept, that's where x is 0. 2 times 0 disappears. We're left with 3y equals 12. Divide by 3, we get y equals 4. So there is that one. And I'm going to add a few more points that I know that are on the graph just to make it a little easier for me to keep these straight. I know that the slope is actually negative 2/3. So I'm drawing this so it goes 3 to the right, down 2. Something like that. Now, again, this one's going to be solid, so like that. And here, y is not isolated, so I really need to use a test point here. I know that I can use 0, 0 as my test point because it's not on the red line. Now, if 0, 0 is a solution, this region will contain all of my solutions. But if 0, 0 is not a solution, I'm going to cross the red line, and they're actually going to be in that region. So these two lines break the graph into 4 regions. For one of them, we shade 2. For one of them, we shade 2. And we're looking for the one that they have in common. So back to the test point of 0, 0. We're working with 2x plus 3y greater than or equal to 12. Put in 0 for each variable. The left side just becomes 0. Is 0 greater than or equal to 12? No. That's false. So we're not going to shade on the side where 0, 0 is. Instead, we're going to cross the line and we're going to shade it above and to the right. So I'm going to use one that's kind of red. And we can see the region where the two shaded regions cross. And so I'm going to switch to one more color. Let's go with green. Where these two crossed, that is where our solutions are. So when you're producing the final graph, the place where the this region, you would erase the shading that's there because it's not part of the solution, and you would erase the shading down here as well because it's not part of the solution. So what we would see is something like this, something like this, and then just that one region shaded. All right, let's try a second one. This one is nonlinear because the first graph is a parabola. A couple of things to notice here. No equal sign, so we'll be using dashed graphs instead of solid. Also, y is isolated, so that helps us to figure out which direction to shade in. We're going to shade above the parabola, but below the line. And that can help us to avoid all the different shadings and where do they cross. We can actually figure this out ourselves without the arithmetic. So let's begin with the parabola. It's in HK form. So the vertex is at 1, 2. It opens up from there. The y-intercept would be at 0, 3. There's a symmetric point over here. And I know that if it's just x squared, not 2x squared, 3x squared, 1/2 x squared, from the vertex we go up 1 and out 1. Then we can also go up 2 and out 4 because 2 squared is 4. We could even go up 3 and out 9 if we needed to. 1, 2, 1, 2, 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, something like that. And so here, oops, again, this one's going to be a dashed line. Now, because it's y is greater than that, I am looking in this area. Let's go ahead and graph the second inequality and look for the parts of that that intersect with the solutions from the parabola. I'll do this one in red. This is a line. The slope is 1, so that's up 1, right 1. The y-intercept is at y equals 3, so that gives me a point to start with, which is actually already on the parabola as well. And then we go up 1, over 1, up 1, over 1, up 1, over 1, and so on. Something like that. Now here it's supposed to be below. In the previous one, because we had y is greater than, we shaded above. Now we're going to shade, so above the parabola but below the line is this region right here. So that shows all the solutions to this system. Now again, we could have done what we did before and then look for where they intersect. So sorry, we could have done, oops, one more time. There we go. We could have shaded this first. Then we could have shaded below the line, and we would have had that one area, that one region where they cross. That's where the solutions are. So let me put the actual solutions back up there one more time. Now, that shows me that they're definitely easier to work with when y is isolated. And if you have an inequality with both x and y in it, then you can try to get, if you can isolate y, it makes the graphing part a little easier. So that's a pro tip, free of charge. The last one is a little different because I've got two inequalities that only have one variable in them. The absolute value of x is less than or equal to 4. Y is less than or equal to 8. And then I've got this absolute value inequality with both x and y. Notice I do have y isolated by itself, which is helpful. I'm going to begin with the inequalities that only have one variable. Also notice that they're all going to be solid graphs because of the equal sign. Now, starting with this first one, we know from a previous chapter that this is equivalent to saying that x is between -4 and 4. And so, draw a vertical line at -4 and +4. And we know that x has to be between there. So all of our solutions are going to be shaded in that piece. So I'm not going to worry about shading that one just yet. I just know that I have to look inside of there. The next one, y is less than or equal to 8. I'm going to draw a horizontal line in red at y equals 8. And all the solutions are below that. So now I know that I am in this piece here. That's where my solutions are going to be. Now I will graph the absolute value function. I will shade inside that box where it's above the absolute value. Because of the greater than sign, I'm going to shade above that. So I'll graph the absolute value function and I'll shade above it inside this little box region that we have. Let's get the big red X out of the way. On to color 3. This is an absolute value. HK is -1, 2. So that is the turning point, and it opens upward, and the slope is going to be +1 to the right, -1 to the left. So -1, 2, slope of +1 to the right, slope of -1 to the left, and we need to shade above that. So inside the two blue lines, below the red line, and above the absolute value, we get, oops, let's switch out, we'll stick with green. We get this region here. Now again, we could have shaded each one separately and then looked for where the three of them overlapped, but oops, I went too far, didn't I? Let's try that again. I'm glad I looked. It's going to stay inside the blue, and I went beyond the blue. A little coloring, that's pretty relaxing, right? So I could have drawn, shaded in blue between the blue lines, shaded in red below the red line, and then shaded above the absolute value and look for where they cross, but this is where they cross. All right, that's it for this one. In the next one, we're going to take a look at something called linear programming.